So today we're going to learn about a new circuit element, and that's going to be a capacitor. So let's make a circuit, a simple circuit with a resistor, capacitor, and a voltage source. So we're going to start with a voltage source, and I'm going to put a resistor in series and our handy dandy capacitor. There we go. Now let's connect them all together. And let's add the ground, our reference, voltage reference for this circuit. Okay. So now let's give the source the value and the resistor capacitor also some values so that we can simulate. So this time I'm not just going to give the source a value. I need to do something a little bit different. So I'm going to go to Advanced. Now I'm going to choose a pulse source. And you might ask why I'm doing this. Well, what I need to do is I need to simulate a switch in the circuit. Let's close this so I can show you what I'm talking about. So what I would need to do is I want to show that at time equals 0, we have a switch here. And this line is open. And at time equals 0, that switch closes and connects the circuit. So I want to see the instantaneous behavior of the circuit when the voltage source is connected to the resistor and capacitor. So if I don't do it this way, if I say that the 5-volt is connected and we just run the transient analysis like we used to for the resistance circuits, then it's not a justified circuit because that would assume that this voltage source has been connected for quite a long time. And what would that mean? If the voltage source is connected for quite a long time in this circuit, that just means that the capacitor will be charged to the same voltage as the source. So if the source is at 5 volts, the capacitor would already have a charge which would equal to a potential of 5 volts. So there would be nothing to see in the circuit. I want to see the instantaneous kind of current or the reaction of the circuit when this voltage source is just switched in, or this circuit, this R and C circuit, is just connected to the voltage source. So the way we're going to do it is we're going to right click on the voltage source, go to Advanced, and click on Pulse. So our initial voltage is 0, and then V on, which is voltage of on, when the switch is basically turned on, is 5 volts, and the time delay, I'm going to say maybe in say 1 second. So basically what that means is from 0 to 1 second in our circuit, the voltage source is not connected. It's at value 0. And at t equals 1, actually, we are connecting the voltage source to give 5 volts to the circuit. So let's run this. We're going to hit OK. Oh, before we run it, we're going to give some values to our resistance and capacitance. So resistance I'm going to call as 1 kilo ohms, and capacitor I'm going to say is 100 microfarad. There we go. And now I'm going to simulate it. Actually, before we simulate, let's talk about it a little bit, what's going to happen. So at t equals 0, we have no circuit. Basically, there's a switch that's open here. There's no voltage source that's connected, or you can say that the voltage of this source is 0. And at that time, there's nothing. Like there's no current flowing in the circuit. It's not a complete circuit. And at t equals 1, we complete the circuit. We give 5 volts to this node. And what would happen basically is that this is a full bucket of water, of electrons, and this is an empty bucket of electrons. So electrons are going to be like, whoa, let's go in to charge the capacitor. And they're going to flow through the resistor and start charging the capacitor. And when would they stop? Well, they would stop when the capacitor is charged to the same potential that the voltage source is at. So we're going to have a current that's flowing from here to here for a short amount of time. And let's see what that current is. So let's simulate and run. I'm going to say time, let's say we run it for 15 seconds. Just give it enough time. So 15 seconds we're running this circuit, and I'm going to now see what the current is. So there we go. Okay, so t equals 0. T equals 0 to 1. we have 0 current because our switch is open. And at t equals 1, we see an instantaneous spike. And let's zoom into this spike to understand it a little bit better. So there we go. All right, so we're gonna say we're seeing 4.8 milliamps of current right when the switch is closed. And then we see it slowly decaying down back to 0. And that's because as the capacitor is charging up, we will have a rising potential at this node. So the flow of electrons will be slower, or the current will start reducing as this bucket is filling up. The capacitor bucket is filling up. So that's why we see this sort of a graph, and as this is basically the capacitor filling up and reaching close to the same voltage as the source. And let's actually just see that voltage. I'm gonna plug the voltage in here. I'm gonna double click. All right, so yeah, so the voltage graph was just hiding underneath the current graph, so unfortunately I won't be able to show both, but together, unless there's a way to, can I add a plot? Yeah, okay, we can do it like this, and then let's add the current up there. All right, yeah, so the voltage is at 1 second, it slowly starts to rise for the capacitor until it reaches the steady state value of 5 volts, which is equal to the source voltage. And similarly, the current starts to decrease. Well, it's a negative current, so you're seeing an increase in current, but technically the current is going towards 0 as the voltage of the capacitor is rising. So there we go. That's like an instantaneous response, a pulse response that we call it for a capacitor. So in the next video, let's look at the mathematics behind it and understand how this really happens and how do we know what this curve looks like, how long the capacitor takes to charge, what the voltage of the capacitor would be at a time instant t. We can calculate all that before we simulate it. So now that you know, kind of have an intuitive understanding of how this circuit works, let's try to dive into the mathematics in the next lecture.